All right. Well, hopefully everybody did pretty good with just turning stuff into base 10 blocks and kind of playing around with that a little bit. So in this case, again, what we want to do is we want to kind of go through some different addition and subtraction algorithms. And so again, this is more of a kind of from an educational perspective. The goal is when we're teaching, if we only show students one way of, say, adding, for example, it's possible that half the class will get it and everybody seems fine, and then there's another class that just doesn't seem to understand that model, and then just what happens is they just start to fall further and further and further and further behind. So our goal is to kind of have as many models and examples as possible, so that way hopefully there's a model that every student can kind of be drawn to, works with the way their brain works, and allows them to kind of be able to do the math the same as everybody else and kind of stay up with everybody without falling behind. So these methods that we're going to do is going to get kind of simpler at the beginning, and then till finally it ends up looking pretty much exactly like our final algorithm, which is probably the way you guys are used to adding anyway. So again, just be mindful of what we're doing, how to do them, and things like that, because again, we want to be able to use these different techniques for students so everybody has a fair chance to learn what's going on. So the five different models that we're going to talk about are kind of the base 10 block model. So again, we're going to turn numbers into base 10 blocks like we did in the last section, add them up, and then use that regrouping that we did in example 3 to turn it into the simplest number that we can. So place value cards, we'll see what that looks like, but it's very similar to the base 10 blocks, but without having to draw kind of everything out. Place value diagram is pretty much similar to place value cards, except for we're going to use numbers kind of instead of dots. So instructional is almost the final thing, but it's not quite there. And then finally, our final standard is probably what you guys are most used to when it comes to adding and subtracting and stuff. So let's start off looking at example 1 here. And so we're going to go through all the different possibilities when we're all said and done. So in this case, it says find the solution to 38 plus 54 using first match strips and blocks. So this is the base 10 block method. So the first thing we want to do is actually rewrite these so that they both look like base 10 blocks. So in this case, I'm going to start with 54 just because it's bigger. And so we need 5 strips and 4 dots. And then 38, we need 3 strips. And then 8 dots. And now we just add them up. And so again, we're not thinking about carrying or anything like that. So we just physically want to just copy the total number of dots that are down and then the total number of strips and then kind of go from there. So in this case, I'm going to start with copying the 4 from the 54. And then to that, I'm going to add the 8 more. So I've got 1, 2, 3, 4, 5, 6, 7, 8. And so at this point, I just leave it like that. I don't do anything yet. And now do the same thing for the strips. So I'm going to bring down 1, 2, 3, 4, 5, and then 1, 2, 3 for those guys. So now is when we start to look and decide, could I regroup? Is there any column that has, more than 10 of something where I could regroup it and move, one spot over to the next one? So if I look again at these guys, I know I've got 10 dots here. So if I take those 10 dots, I can bring those guys over and make a single one there. Let me just kind of highlight that. And when I do that, just kind of remember that gets rid of those 10 dots because I've just moved those 10 into a new position, basically into the tens position. So in this case, I'm done with my ones because all I've got left is just a 2. So I can bring my 2 down. And so now I want to kind of look at the tens position and see the same thing. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's just 9 there. So there's nothing to regroup. So I can just bring my 9 down. So it looks like my answer to 38 plus 54 would just be 92 in this case. All right. Is that okay with everybody? All right, perfect. So that's our base 10 block diagram. So now what we want to do is move to the next page and do the same thing with place value cards. So with place value cards, so notice we'll have a big table. We'll have a ones position, a tens position, and a 100s position. And so what we're going to do is we're going to expand, you kind of use expanded notation to write these different numbers. But instead of using the numerals, we're going to actually just put dots for each one of them. So in this case, I want to add 38 and 54. So let me just write that up here so I don't forget. So what I'm going to do is first represent 54 using a bunch of dots. So in this case, 1, 2, 3, 4. So I'll have 4 dots in the ones position. 1, 2, 3, 4, 5. 5 dots in the tens position. And so that's my number 54 in this case. So now in the next column down, or next row down, I want to do the same thing and represent 38. So I've got 1, 2, 3, 4, 5, 6, 7, 8. And then again, 30, I want to represent by 3 dots in the tens column. And so again, I've got both of my numbers represented in my place value cards. So now I want to do the same thing. I just want to add these guys up. But again, I want to add them same way I did the blocks over there. I don't want to start combining and things like that. I just want to bring the dots straight down. So again, I'm going to start here, bring those first 4 dots down. And then I need to bring 8 more dots. So 1, 2, 3, 4, 5, 6, 7, 8. And again, at this point, I'm not doing anything with them. I'm just leaving them be. So now do the same thing with the tens column. So 1, 2, 3, 4, 5. And then bring down my other 3. So now that we've added these guys all together, now it's time to start figuring out whether we've got, 10 in any given column. And so again, just like last time, I can take these 10 dots and kind of put them together. And what I'm going to do, I'm going to put a little spot down here. I'm going to take these 10 guys and turn them into a dot in the tens column now. And so once I've done that, that eliminates those 10 from the ones position. And so there's no more left in the ones position, so I don't have to worry about any more regrouping there. So I can go ahead and bring these 2 dots down. So now what I'd want to do is kind of look at what's up above. And so, by bringing this dot over, did I make 10? Were there already 10 there? And so the answer is no. So there's nothing else to regroup in the tens position. So I'm just going to go ahead and bring down those 8 dots we had above. And so now I've got 8 plus the 1 in purple gives me 9 dots in the tens position, 2 dots in the ones position. So my overall answer, luckily enough, was 92. So I didn't mess anything up or anything like that. So that's good. All right. Is that okay with everybody for place value cards? So it's kind of one step above using the base 10 blocks in this case. So it's still, so we haven't actually put really numbers anywhere. We're kind of just adding dots up and things like that. So we're not doing anything major in terms of arithmetic. It's really just counting at this point. So place value diagrams is where we finally sort of introduce the numbers into the mix. And so again, what we're going to do is write this in expanded notation by placing each of the numbers in the right column. But instead of actually using the dots, we're going to use the actual numbers in this case. So when I'm trying to add 54 plus 38, then that means I want to have a 5 in the 10 spot, and then a 4 in the 1 spot. And then same thing for the 38, a 3 in the 10 spot, an 8 in the 1 spot, and then add them. But again, we're not doing any carrying or anything like that. We just want to add them straight up this first time around just to kind of see what happens. So in this case, I get 8 plus 4, which gives me 12 things in the ones position. 5 plus 3 gives me an 8. And so it looks like 812 is my final answer. Is that right? Of course not. No, it's not right. So and it even looks weird, because we've got 8 in the tens, but we've got 10 or 12 in the ones. So again, just like over here with the dots, since we've got too many things in the ones position, or we can move some of those ones over and make an extra one in the 10 spot. So in this case, what we're really doing is taking that one that's in front. Oops, I don't want to do that. Sorry. And transferring it over and putting that extra one in that spot. So in this case, we're taking those tens and just moving it over. And so when we do that, that eliminates that 10 ones that we had, and we turned it into a single one in the tens position. So at this point, we've got our 9. That's all that's left over in the ones. And now in this, we've got 8 plus 1 that gives us 9 in the tens column. So our final answer, again, like I said, we didn't do anything wrong, which is good, is 92 in this case. All right, is everybody doing okay so far? All right, perfect. So instructional algorithm kind of looks similar to what we just did with the place value diagrams, except there's no chart. So we're just kind of keeping track of the units and the tens and the hundreds and all that stuff by ourselves. By when we write our answer, we're going to keep a row for units. We're going to keep a row for tens. We're going to keep a row for hundreds and things like that. So let me show you what I mean here. So if we're adding, so it starts off looking just like a normal addition. But when we add this first row together, 8 plus 4, when we add our units together and get 12, we actually want to write it just like that. We want to write it as 12, and this is our kind of units row. And then in the next spot, what we're going to do is add our tens together. So even though we're just adding the 5 and the 3, we want to think of this as 50 plus 30. So that way we preserve that unit spot and everything lines up exactly the way we want. So in this case, we're going to add 50 plus 30 and get 80. And that's going to be our tens position. And if we had something out in the hundreds, we'd add the hundreds up, and then we'd have a hundreds row. And if we had something in the thousands, we'd add the thousands up, and we'd have a thousands row. But we would keep this same notation down below. And then once we finish adding up all of our columns of numbers, then we finally add these two guys together to get our final answer. And so 8 plus 1 is 9. So again, we get 92. So again, a little bit more complicated than place value diagrams, but it's almost exactly to the final algorithm. And so final algorithm is what you would normally think of where you do kind of the grouping on the fly. So in this case, 8 plus 4 is 12, carry the 1. 5 plus 1 is 6, plus 3 is 9. And so again, we end up getting 92 the same way. So again, you can see, they kind of start off, where you really don't have to know a whole lot of, any kind of math, no number facts, none of that stuff. Really, as long as you can count, you can actually do these additions of fairly big numbers. I mean, just by kind of the way we structure everything, we order them in terms of columns and stuff like that. Then it gets a little bit more where we're actually using the numbers and the columns. Then we take the columns away. And then finally, we get to the final algorithm, which you guys are, again, probably most familiar with. So if something doesn't make sense or anything like that, please ask. Just let me know. Otherwise, I'm going to move on to subtractions here. And then I've got a bunch for you guys to practice of each kind. So in this case, we've got example 2, which is doing the same kind of idea, but we want to do subtraction this time. So in this case, we've got 107 minus 17. So using our match strips and blocks. So again, first thing we want to do is we want to actually write down each of these in terms of their mat strips and blocks. So 107 would be one mat or a square. So 0 strips, but I'm going to leave some space for them, and you'll see why in a second. And then 7 dots. So 1, 2, 3, 4, 5, 6, 7. And then for our 17, we've got one strip and then 7 blocks. And then the goal is we want to subtract these guys from each other. And so what we're looking at is kind of like the takeaway method when we were doing our modeling in the last section. So we're trying to take away as many block numbers or strips or whatever we can from each of these different problems. So like in this case, I've got 7 on the top and I've got 7 on the bottom. So I'm taking 7 away from 7. So in this case, they actually just cancel each other out. And so I'm going to end up with a 0 in the ones column in this case. So now the goal is I'm trying to take 1 away from nothing. Well, I can't really take 1 away from nothing without somehow going into debt. So this is kind of the same idea of the grouping that we were doing before, but now what we want to do is ungroup it. Because in order for me to take 1 strip away from 107, I have to actually have some strips to begin with. So what I'm going to do is I'm going to take this block and I want to cache it in and like basically break it apart into strips. So since it's 1 block, remember I can turn 1 block into 10 strips. So I can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this case, I've taken these 1 mat or 1 block and turning it into 10 strips. And by doing that, now I can actually go through and use my takeaway method to try to figure out like what the answer would actually be. So in this case, since I'm trying to take away 1, that's what I would do. I would just kind of circle 1 on the list and say, okay, well, that's gone. And then whatever's left over is going to be however many 10s I have left. So in this case, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 9 strips left over. So bring my 9 down. And so my final answer in that case would be 90. All right. Is that okay? So the only difference is with subtractions, we end up, if we have to regroup or something like that, we do it in the beginning. Like we break a group apart in the beginning so we can actually do the subtraction. Where in addition, we wait and do it at the end. So we do all the addition stuff first. We look and see if we've got more than 10 in any row or column. And then we adjust. Here we're going to adjust in the beginning if we need to. And then we won't have to adjust our answer. That's kind of the nice thing. So, all right. So place value cards. So again, remember this is where we're going to be using our dots to represent each position. So again, I'm going to do 107 minus 17. So the first thing I need to do is write them in kind of their expanded form. So I'm going to get a 1 for the 100 and then 7 dots in the ones position. And so that's my number 107. And then 17, I'm going to get a 1 there. And then 7 dots in the ones position. And so again, it's time to subtract these guys. So again, just like above, I can take all of these guys and they all match up. So I can just take all of those guys away. So that leaves me nothing in this last column. So I've got a 0 in that position. And so again, in this case, I'm trying to take 110 away from 010. So again, this just isn't going to work. So I've got to cache that 100 in and turn it into a bunch of 10s. So in this case, I'm going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's my 10 10s, which is the same thing as 100. But now that I've actually got 10s there, it makes sense to talk about taking away 1 from those 10. So let's just circle one of those so that we can take them away. And so again, that cancels those guys out. So all that's left now is just to bring those 9 dots down. And so again, now just turn it into a regular number. So I had nothing in the right-hand column, so I just brought down the 0. I've got 9 here. So again, we end up with 90, just like we had before. So, all right. Everybody okay so far? Perfect. All right. So again, place value diagram, we're going to do kind of the same thing that we did before, except without using dots. We're going to use actual numbers in this case. So I'm going to write 107 to represent 107. And then I'm going to write 17 to represent 17. And then again, we want to subtract these guys. So in this case, we've got 7 minus 7 would just be 0. But again, here I'm trying to take this 1 away from 0, but there are no zeros there. So what I have to do is, again, kind of regroup this guy and rewrite it so that it looks like something that we can actually do. So again, I'm going to take this 1 and I'm going to shift it back over so that it becomes a 1 there. So we're basically taking that 1 100 and we're turning it into 10 100s. So exactly what we did there. So I've got the number 10 in the tens position, and now this guy is gone. So again, what I'm doing is taking 10 minus 1, which is our 9. And again, that gives us our final answer. So we're getting closer to regrouping. So we're not, or the final answer, or final algorithm, we're not quite there, but we're getting closer and closer. So instructional, so again, instructional is going to look kind of the same way it did for addition. We want to keep kind of each row separate. So there'll be a ones row and a tens row and stuff like that. So again, there's no columns this time. We just write everything out in real numbers. And so what we're looking at is, again, we're going to take 7 minus 7, subtract the tens position or ones position first. And so that gives us a 0 in our ones position. And so in this case, so again, we kind of run into that same problem where we've got, we're trying to take 1 from 0, but we can't actually take 1 from 0. So what we end up doing in this case is kind of reshuffling this around and looking at rewriting this 1 just like we did before and bringing this over and making it a 10. So what we're really looking at is, oops, oh shoot, wrong thing. Oh, hold on, right now I'm writing this bad. So we're really looking at kind of 100 minus 10 in this case, which is the same thing we kind of had, but we're thinking of this as like in the tens position. So 100 minus 10 in this case would give us our 90, and this would be our tens position. And then finally, we just want to add these guys up once we've done all of our subtractions. And again, if there was something out in the thousands, we would just keep doing this over and over and over the whole way down. So that gives us, again, the same thing, final answer of 90. And so finally, the final algorithm, we just we'll kind of collapse that last step. We won't have the different rows for each and every one of them. So in this case, 7 minus 7 would be 0. And here, we know we can't subtract 1 from 0, so we carry this 1, bring it over, make it a 10. 10 minus 1 is 9. And so again, we would do it all in one step as opposed to having kind of these two separate rows for each one of them. But again, just like the addition, we kind of started off with all you really needed to do was know some counting skills. You didn't have to know really any math facts or anything like that. And progressively got a little bit harder so that if you knew the math facts, it would definitely make life a little bit easier up until we get to our final algorithm, which again is probably the one that we're most familiar with. So again, these techniques are nice because it allows students, that are struggling with one or more of the techniques to hopefully find one that they can really work on, that they really know how to do well, and they can kind of focus on that and stay up with the class and be, kind of successful at math. All right. So there's a bunch on here for you guys to practice. So I'm just going to kind of leave it at this. So, I mean, there's tons and tons for you guys to work on. If you do have any questions, again, this is all about the model. I'm not worried about, I mean, I do want you to get the right answer, of course, but again, the focus is more on practicing the model, making sure we're actually following the model correctly. So if you're getting stuck or you're having a problem, take a picture of your work and send it to me so I can let you know whether you're on the right track or not. Otherwise, if you have any questions, I'll be around all day tomorrow. So good luck, and I'll talk to you tomorrow.